Okay. Welcome to another session. Today we're going to continue and do more exercises related to more activities related to study unit 7, and then after that we would have concluded with the revision of study unit 6 and 7, and then we will look at doing the revision using the assignment question for study unit 8 and 9, which is confidence interval and hypothesis. But let's continue from where we left off yesterday. All the recordings are uploaded, so you should be able to find all the recordings. So also remember that with study unit 7, where we left off, we're still going to find the probabilities on the table, and we are still going to standardize the values. So I think we ended with question 9. So we'll go on with question 10. Okay, that's where we were. There is some mistakes this question, but it's fine. So question 10, the emotional intelligence quotient, which is EQ score of a grade 8 class, is normally distributed with the mean of 80, the standard deviation of 20, a random sample of 36 grade 8 learners is selected. Let X be EQ score of grade 8 class. So based on what we are given the mean, which is your mu. You are given your standard deviation, which is your sigma. You are told that there are 36 grade 8, which is your n. And we need to find let's read the question. Let X be the EQ score of the grade 8. It is further known that the probability that the mean EQ score is at most X is 0.96. There's some errors on this question. Capturing of it is not so good. Okay. So it is further known that the probability that the mean EQ score is at most is 0.9646. What is at most? At most, it is less than or equal. Determine that the value if X such that determine the value of X such that the probability of X is less than, or I don't know what that, whatever this is, there's something wrong with this question. In a way, we starting the session very wrong. The probability of X is less than or equals to X is equals to 0.96. So what actually this should have been a capital letter X on there. So what they are asking you is, let's find this value of X, the small x. If we know that the probability of this X less than the small x is equals to 0.9641. So what does that mean? It means in order for us to find the value of X, this value of X, I'm not sure whether this is the value of X or this is the value of Z. That's how this question is structured that I don't even know what is happening here, but I think here it should be Z, not X, because this is the standardized normal distribution value. So, but we need to find the value of X. No, we need to find the value of X. It's correct. This should be capital letter X. This should be the capital letter X. But we know, okay, if we go back to what we know that this probability of X given by this value is the same, or we got it by finding the probability that Z is less than or equals to, I'm gonna write the formula, minus the mean divided by the standard deviation divided by the square root of n, and that gave us the value of 0.9641. So what does that mean? It means this value here, we found it on the table and it was this. So if we can go and find the value of Z, the Z value that corresponds to this value, because the sign says less than or equal, therefore it means the probability we find on the table will be that. So we need to go to the table and get the Z values. So let's do that. Our probability is 0.9641, and because it's 96, we will find it on the positive side of the table because it's the bigger probability. So we go to the positive side and we look for 9641. We are going to look for 9641. So let's look for 9641. 999895 96696, and there is 9641. And 9641, okay, let's remove this. It corresponds to that Z value, and the last digit is 0. So it is 1.80. So going back, we can take away the whole formula and say we're using only what is inside this bracket. Our Z is 1.80 is equals to our X, which is the small x that we are looking for, minus our mean they gave us is 80, divided by the standard deviation is 20, divided by the square root of 36. We can ignore the inequality sign and just use the equal sign. So if we apply math, we're going to take whatever is at the bottom and multiply with 1.80. So let's do that. So it will be 1.80 times 20 divided by the square root of 36 is equals to x minus 8. And if you apply math at the end, 80, you will add it on the other side, right? It will move to the other side. So if we move 80 to the other side, then it becomes, because I'm running out of space, it will be plus 80 is equals to x on its own. And that will be the value of x that we are looking for. So let's do the calculation. I'm gonna use my calculator. I'll use the sharp. Those people with the sharp calculator are struggling. Let's go with the sharp and show them how do we do this. So on my sharp, I say 1.80 multiply by, open bracket, 20 divided by the square root of 36, close bracket, and I can say plus 8. I'm going to wait there and wait for you guys to do the calculation and let me know what the answer is. If I did it right. Let me also do it with my Casio. Hmm? Do you have the answer? I'm waiting for you to give me an answer.
86.
I'm getting 86.
Okay, on my Casio, I'll say 1.80, open bracket, and I will put the fraction and say 20 down, square root of 36, out again, close bracket, and say plus 80. And let's see, it's 86. And let's see on here, it will be 86 as well. So the answer is,
It's giving me 80, why?
there must be something that you did. Which calculator are you using?
Using Casio.
A Casio. So
And
check.
to follow your steps.
Yes, check your formulas or how you captured your data.
Yeah, I said 1,80, open bracket, and then I followed to the thing, 20 over 36. And close bracket plus 8, and it's giving me 81. How did you get to 86?
Are you sure your close bracket is on the right spot as well?
Yeah. Okay, can you repeat that? Maybe let me please. Sorry, guys.
Just want to check something. Okay, it should have given you an error if you didn't put it right. Okay, so it's 1,80, open bracket, and then you do the fraction thing, and you put the 20, and you go down with an arrow, and you put this root function, and you put 36, and you go out twice with the right arrow, and you put your close bracket, and you press plus, and you say 80 and equal 86.
Oh, yes. Now that's correct. Thank
Okay.
you.
Number 11. In a sample of 200 schools from Nyati District Municipality, 144 schools reported a decline in the number of learners. Now, this is sampling distribution for the proportion. For the proportion, if you are not given P, you need to know that P is X over N, and we're going to use the Z-score of Z, P minus the population proportion divided by the standard error, which is your population proportion 1 minus population proportion divided by N. If you are not given the population proportion, you can calculate the standard error, and here your standard error will be the standard error using your population proportion times 1 minus the population proportion divided by n. Or if you are not given the population proportion, you just use your sample proportion 1 minus the sample proportion over n. So based on this question that you have, they have given you the sample size, they have given you your observations, right? So they didn't give you the population proportion. So you have your n and you have your x. The next question is, and remember what I said, this is your standard error, and the standard error is always the value underneath there in the fraction is your denominator. Calculate the standard error of the proportion of schools that reported a decline in the number of learners absent and choose the correct answer from the list of options below. So we need to calculate the standard error. And since we are doing the proportion and they didn't give us the population proportion or even the sample proportion, we can calculate the sample proportion by using the formula x over n. And our x, it's 144 divided by n of 200. What is the sample proportion? It's 0.72% or 72%. So it's 0.72. So we need to calculate the standard error, which we will use the sample proportion 1 minus the sample proportion over n. The square root of our sample proportion is 0.72 times 1 minus 0.72 divided by our n is 200. Let's go with those who are using a sharp. We're going to work first with what we have in the inside the root. So we're gonna first remove the bracket. So it's 1 minus 0.72 equals, and that removes the bracket, and we multiply it with 0.72, 0.72, and equals, that gives us the top part, and we need to divide by 200. So divide by 200, and that is everything underneath the square root. Remember, we need to take the square root of the answer. You just press the root button and you press the equal sign, and the answer is 0.0332, which will be option A. Let's see, on the Casio calculator, you use the root, you put the fraction, you say 0.72, open bracket, 0.72, 1 minus 0.72, close bracket, go down with an arrow, and put the 200 and say equal. And you get the same answer. We have the same answer, 0.03174, 0.03174, which is option 1. Easy, right? Are we good? Are we happy? Happiness? You are so quiet.
Lizzie. Hi, Lizzie.
Yes.
How did you get the 0.72?
By taking your value of your n, which is your sample size of 200,
Yes.
and the value of the 144, which is your x observation, the number satisfying this decline of the number of learners absent, which is your x outcome, and calculating the proportion, the sample proportion. So it will be 144 divided by 200. Unless if I didn't calculate right. We can go again. 144 divided by 200 is equals to 0.72.
Okay, yeah, great. That's where I'm getting. I got
Let's
that 18 over 25. And then how did you get to 0.72?
By taking
That's where I'm struggling.
by taking the 144 and dividing it by 200.
Is for you to
Yes.
get 72, what do I press on my cashier? 0.72.
144 divided by 200.
Yes.
And that should give you, oh, I see. Oh,
Yes.
SD button.
I am so
SD.
sorry. You
S?
must press the SD function. There is this button
Oh, okay.
called SD button. Can you
Thank
see
you.
that?
Okay.
Oh, sorry.
Okay.
Are there further questions? Are we good? Okay. Let's move on. Consider the population proportion. I hope you did write that formula down, because now we're talking about the population proportion. Remember, population proportion is denoted by the pi sign on that side. So consider a population proportion of 0.055, 0.55, and a sample proportion of 65. Given the sample size of 99, determine the value of the test statistics and choose the correct answer below. So a test statistic is your Z value, which is, we're talking about the proportions, which will be that formula that we wrote. Your sample proportion minus your population proportion divided by the square root of your population proportion, 1 minus the population proportion divided by n, which is divided by the standard error. What are we given? We're given the population proportion, and we are given the p. We are also given n. You just substitute and calculate. Our p is 0.65 minus our population proportion is 0.55 divided by the square root of 0.55 times 1 minus 0.55 divide by 99. Zero 0.65 minus 0.55. Go down, take the square root of a fraction, 0.55 times 1 minus 0.55, close bracket, go down, and put the 99, and I will wait for your answer. Those who are using the sharp calculator, it's just that now my sharp calculator is so huge with the screen on the side, so it will hide. So in order for us to answer that question, so on your sharp calculator, you will have to do this step by step. There is no shortcut unless if you use brackets. And I'm going to teach you how to use brackets, because otherwise you know how to use your calculator. You can calculate this. by breaking it down, by calculating what is at the top, writing the answer, and then calculating what is at the bottom, writing your answer, and combine all of them. But now you need to make sure that you do not round off your answers as you write step by step. So I'm gonna do the whole thing on this calculator. If you don't know how to use your calculator properly, do not do what I am trying to do right now. So I'm gonna start with the top part. So I'm gonna put the top part into bracket, and I'm gonna divide by the bottom part, and I'm gonna put the bottom part into bracket. All calculators have fractions, so I have arrows. So it's easy with the top part because the top part is 0.65 minus 0.55. That is easy. Going into the second one, it is that mission and a half, because in the second one, there is the root. So I need to make sure that I take care of that root. And because the root has a fraction, therefore it means I must use the open bracket for everything, right? So I must remember to close that bracket of that root, because now I have the closed bracket as well. So I must remember that. Now I need to work out what is inside. So I must go back out to the first bracket and work out this. So 1 minus 0.55 is the same as 0.445. So I can just say 0.45 times 0.55 divided by 99, because in terms of BODMAS rule, multiplication and division have the same priority. I can work from left to right. So that one is that sorted. Let's hope I'm gonna get it right. So I'm gonna press the equal sign. And my equal sign says my answer is 2. So let's see if the answer is 2. Can you see there? It says my answer is 2. Not me, is my calculator. I can validate that answer by using this. The Casio, what is your answer?
2.
I got 2.
2.
The Casio.
And the
2.
answer is 2. So you need to know how to use your calculator. All calculators can do the same thing, but you just need to apply your mind when you are using either calculators. And the answer is 2. 2, 2, 2, 2, 2. And that's how you calculate your test statistic. Previous study has shown that only 84% of schools in the Amatole District Municipality have reported a decline in the learners' absence since the start of the learner transport and the school nutrition program. Because it's previous study, that is our population proportion. Suppose that 99 schools in Amatole, which is our sample size, is drawn at random. What is the probability that more than 90% of the school have reported a decline? And 90% is our P. What is more than? More than is greater than, right? So what they are asking you is to calculate the probability that more than 0.9, maybe I can say 0.90, find the probability that the sample proportion is more than 90%. In order for us to find that, we need to standardize our probabilities. So we use the formula P minus P proportion divided by the population proportion 1 minus the population proportion divided by N. So substitute the values. The P, small p, is what is given in the question, which is 0.90, minus our population proportion, which is 0.84. How to get 84% to decimal? You just divide this by 100. It will give you the decimal. Divide by the square root of 0.84 times 1 minus 0.84. Oh, yeah, 0.84 divide by 99. And close bracket. So what is our Z value? And I must keep the sign. The sign is greater than. I must not forget that, because it's very important when we go find the probability. Remember, the answer should be in 2 decimals. What is the answer? We're still calculating. No one. The answer is 1.63. 1.63. Keep it to 2 decimals. 1.63. What needs to happen? We'll have to go to the table, right?
Table.
And go do 1 minus the value we find on the table, so that we can get that to the answer. So we go to the table on the positive side, and we look for 1.63. Remove the ink. We're looking for 1.63. So 1, 6, and a 3 at the top. And the answer is 0.9484. So 1 minus 0.9484. In the exam, you will find that is an answer and you will get it all wrong. So the answer is 1 minus that. What do you get?
0.0516.
0.051. And that's how you will answer the question. Always remember when we calculate the probability, if it's the probability of Z less than a value, that will be the value we find on the table. If it's Z greater than a value, that will be 1 minus the value we find on the table. If it's Z, or if Z lies between two values, if it lies between two values, we're going to take the value from the table of the second part, which will be the bigger value, minus the value we find on the table of the smaller value, which is the first one. Always remember that. And that is study unit 7. So we can move on to study unit 8, which is confidence interval. Are there any questions?
Sorry, Lizzie, I just want to confirm that number 12, the answer was B.
Number
12.
The answer is D, yes.
D, delta.
Yes.
Okay, that's 13 on the screen. I got that.
Remember the thing was 1 minus 0.9484.
Yes.
Yes.
I got this one. It was question number 12, not 13 that I'm querying.
Oh, 12.
Sorry, I just wanted to confirm the answer on question 12. Yeah, that one. Is it B for
B.
Bravo? Okay,
Yes.
thank you. Thanks so much.
No problem. Where am I at? This one. So we're going into study unit 8 and 9. Probably we won't get to study unit 9, but let's start with study unit 8. Remember, study unit 8 is confidence intervals. With confidence intervals, there are 2 for the mean and for the proportions. And if it's for the mean, also there are 2 when the population standard deviation is known and when the population standard deviation is unknown. For the proportion is just one thing. So you will also remember for the proportion, if you are not given the sample proportion, you will have to calculate your sample proportion by using your P over XN. Now, for confidence interval, when the population standard deviation, which they will tell you population standard deviation, or they will give you sigma, if they are not giving you sigma, they would have given you S, which is the sample standard deviation. And that means population standard deviation is unknown. So when the population standard deviation is known, we use the mean plus or minus, which is the point estimate, plus or minus, remember, the minus means the lower bound, the lower limit, and the plus means the upper limit. So you need also to remember that. So plus or minus, it means you're going to calculate lower limit and upper limit. Plus or minus the critical value, which is your Z, for when the population is unknown. Oh, sorry, when the population is known. And we're going to find the critical value by using alpha over 2. And remember, your alpha over 2 is that probability you find on the table, right? Alpha over 2 times the standard error, which is the population standard deviation over the square root of n. If it is unknown, we use the point estimate plus or minus t alpha over 2 and the degrees of freedom, and your sample standard deviation divided by the square root of n. Right? So we can get to, so the Z critical values, remember you have the table. The summary thing has the table that summarizes your critical values. If you don't know how to find the critical values on the Z table, use that table as a summary table for you, for quick and easy to use. But for the T, you will have to go to the T table to go find the critical values, because you need your degrees of freedom and your probability value. We'll get to that. For the proportion, you use the sample proportion plus or minus Z alpha over 2 and times the sample proportion 1 minus the sample proportion over n, which is the standard error. And that is how you will find the confidence interval. Remember also the value here, all these values, including the critical value, the value before the plus or after the plus or minus, this value, we call them marginal or margin of error, sampling errors. So if they ask you only to calculate the margin of error or the sampling error, you just use those formula right after the plus or minus. Okay. Now it means we're introducing a table, a T table. You need to know that when your population standard deviation is not known or given, they will give you your sample standard deviation, which is S, or they will tell you that this comes from a sample, the standard deviation from a sample. You must know that. You need to be able to read the question to understand which standard deviation they have given you, or they are giving you, or they have given you. That's English. For you, I speak Tswana. Let's go and answer the questions. Number 1, a random sample of 100 results in a sample mean of 100. Sometimes when I read the questions, I don't even hear myself read them correct. A random sample size 100 results in a sample mean of 100. The population standard deviation is known to be 35. What is the value of the standard error? So we're working with the mean. What is the value of the standard error? Which they're telling you that the population standard deviation is known. So therefore it means they have given you the population standard deviation, and we just calculate the standard error. The sample is n, that is the sample mean, and the population standard deviation is 35. Just substitute and calculate. Who is making noise? Makoji.
Thank goodness. John.
And Sanele. Good. Where was I? So let's calculate. Substitute. What is our population standard deviation? It's 35. What is our sample size? The square root of 100. What is the answer?
3.5.
It will be 3.5 because 35 divided by 10, the square root of 100 is 10. It will be 3.5. So 35 divided by the square root of 100 is 3.50, which is C. You see, all these chapters, they are linked to one another. In the exam as well, when you answer the question, there will be 2 questions per each chapter or per each section, because the first session might be out of 13 question and the second session might be out of 13 question. So it means, because you're writing from study unit 1 up until study unit 6 in one session, study unit 7 up until study unit in another, you must just expect 2, 2, 2, 2, 2. You should be able to flow from one another. Or the question should flow from one question to the next as a build-up, because all study units build up. Okay, so moving on to question 2. Consider the population mean confidence interval estimate provided in this list of options below. The confidence estimates are for the same population mean and are calculated at the same confidence level using different sample size, N1, N2, N3, N4. Being N1 being the smallest of the sample size and N5 being the largest sample size. That is, N1 is less than N2, N2 is less than N3, N3 is less than N4, N4 is less than N5. Which one of the confidence estimate interval was calculated using N2? And that is when you start scratching your head and start thinking, what are they asking me to calculate here? So, which is very difficult to do and think, but what they are trying to do and ask you is that based on the sample size, if you have a small sample size, N, which is your N, if you have the small sample size, does your limit become bigger or do they become smaller? That's all what they're asking you. Does your limit become bigger or do they become smaller? Now, if you are given the confidence interval and you know that when you increase the size of your confidence interval, what happens to your confidence limits, then you should be able to answer that question. That's what the question is asking. There are several things that you can do. Either you can test the validity of that, or you can test it by using your own understanding, by calculating something and then using that. Because yes, because when you increase your sample size, it will decrease the width of your confidence interval. So if we increase the sample size, it will decrease the width of your sample size. Let's test that. I'm gonna make an assumption. We can calculate both. So let's use a 95% interval. So we're going to use the mean plus or minus critical value of Z over 2 and your population standard deviation divided by N. I'm going to assume most of these values, the only thing that is going to change will be my N. So we're going to start with 100. What did we have on the other side? The mean of 100 and the standard deviation of 35. We can use this. The mean, we have the mean of 100. And what else do we have? We have the sample size of 100. We have the sample size of 100, yes, and the standard deviation of 35. And I'm going to use Z alpha over 2 of 90%, which is 1,96 onto here. So what we need to do is just increase the value of N. So because what they are asking is what will be N2. So we'll have to calculate this 2 times. So we'll start with 100 and then we go to 110 and then we go to 120, right? And that will help us to determine how do we see the change. We can also use just only the lower boundaries as well. Okay, so let's do that.
Sorry, Lizzie, how did you choose 110 and 120? Where does the increment of 10 come from?
I'm using the example that they gave us previously. Just humor me on this one, then I will show you what I'm trying to get to. Because here we are not given what the standard deviation is. We are not told what the sample mean is and all those things. So I cannot use that. I can use only the information that I know of. But I'm going to create or generate this using the same information. So let's do that. So the first one is 400 for N of 100. So the mean plus or minus Z alpha over 2 times the population over the square root of N. That's where we're going to calculate the first one. The second one, Z alpha over 2 sigma over the square root of N. And the third one, plus or minus Z alpha over 2 sigma over the square root of N. So let's start here. So our mean is 100 because the mean stays the same because they say everything stays the same. The only thing that changes is your sample size. Plus or minus 1,96 times what is the standard deviation of 35 divided by the square root of 100. We know that that was 3.5. So you can calculate that. So you need to calculate those intervals. Then the next one, 100 plus or minus 1,96 times 35 divided by the square root of 110. And then we can calculate the intervals. And then we come here and we do the same. 100 plus or minus 1,96 times 35 over 120. Because I've increased. So N1 is bigger than N2. Sorry, N2 is bigger than N1, N3 is bigger than like that. That's the same concept that they are using. So we just employ the same concept because then we can sort the information we get based on what we get here. And we can use the lower limit. We don't have to calculate the upper limits. Don't worry about the upper limits. Let's use the minus, only the minus side. So I'm going to remove the plus, just only calculate the minus only for now, for each one of them, which should be quick and easy for you to calculate. So you just say 100 minus 1,96 times 35 divided by the square root of 100. And the answer you get is 93.14. So 93.14. Then I go to the next one, which is 110. The only thing I change is 100. Sorry for those who are using the sharp calculator. Unfortunately, 93.45. 93.45. And we only need to change the value of our n, 120, 93.774. 93.74. So what does that tell me? It says when I increase the sample size, the value of my lower limit increases as well, right? So let's assume that our smallest value is N1 in terms of the lower limit. The value with the smallest lower limit is, in terms of all these values that we have here, is 34, right? That's the value with the smaller lower limit. So the second one would be B. But that is also not the case, because that's not what we actually need. What do we need? Let me calculate also the upper limit. So sorry, my mistake as well, because if the difference between the lower limit and the upper limit is bigger for each one of them, then we have a problem. Sorry, it's not what I want to explain. Let's delete and put the plus, which is 106. 106.26. Okay. Just want to check something as well. Okay. The lower limit, 106.54. 106.54. And you can see that this and that is bigger than that. So it will boil down to the size of the width of your lower limit and the upper limit, not what I assumed originally. 100 is 106.86. 106.86. Okay. So, but it's still the same. No, it's still the same, because the lower limit, the upper limit also decreases. Therefore, it means the distance might still be almost more or less the same, because A90 106.86 minus 93.14, which is 13, the difference might also be almost the same with 106.54 minus 93.45, which is 1309, which is 13. So the difference is the same. So yes, so you can look at the lower limit or the upper limit, because if we look at the lower limit, the second one will have the highest, the second lowest, than the third, then the fourth, then like that, because it will increase. The more the value of n increases, the more your lower limit will increase. The higher the lower the size of your sample size increase, the lower or the lower your upper limit decreases, it shrinks, as you can see with this. So if we look at this, the scenario is correct because the smaller the lower limit will be your smaller n. The higher the lower limit will be your bigger n. The smaller your upper limit will be your bigger n, and your higher your upper limit will be your smaller n. So if we look at this, the n's are increasing with the bigger the lower limit, and the upper limit, the higher the sample size, the lower your upper limit is. So it's still, the answer will be big regardless. So that is in terms of your value of your n. So you'll have to test this. If they ask you about the standard deviation, you will have to change the value of your standard deviation to look at how does it affect your confidence interval. Otherwise, if you are not lazy to read, you can go and read about it on the notes. It's there. They do explain that how your sample size changes your confidence interval, the shifts in your confidence interval. Whether if you increasing your sample size will decrease the width of your confidence interval and make your interval more precise. So hence the smaller your class intervals will shrink. If we increase the sample size, then the standard error will decrease, which is this part, the second part before the critical value. Which will in turn will reduce the length of your confidence interval as well. And that's all what they say. But in terms of what we just proved, you can also use that methodology to apply logic on the options to find which one is the second one, because the second one is N2. If they would have said the third one, then we would use the number C as the answer, because then the logic would have applied to that. I hope it's clear, and I hope you don't get this kind of a question in the exam, because then it's time consuming, because you need to test something if you don't know it by heart. And this is the easiest way of testing the logic. Usually it's easier if they would have already given you similar questions or this kind of a question before, and then you can use that as an example to showcase this, because sometimes they might say, when we change your critical value, what happens to your confidence interval? Does it get narrower or bigger or things like that? So you need to know those answers. Okay, moving on. The Department of Basic Education earlier findings from a survey of 90 learners suggest an average travel time of 114 minutes from home to school at one of the schools of interest. Assume the population standard deviation of the learners' travel time is 72. Did they give us the population standard deviation? Is it low? No. So the population standard deviation is known. When the population standard deviation is known, therefore we're going to use point estimate plus or minus the critical value of Z alpha over 2 times the standard error. Now, how do we find Z over 2? Construct a 95% confidence interval. Remember, a 95% confidence interval is the same as 1 minus alpha, which in a way, alpha is equals to 0.05, because it will be, if we take alpha this side and take 95% this side, which is 0.95, 1 minus 0.95 gives us 0.05. And therefore, to find the critical value, we use Z alpha divided by 2. Therefore, it will be Z of 0.05 divided by 2, which will give you Z of 0.0250. 0.0250. And we need to take this value, or you go to the summary table that I shared with you as well, and also on the notes, and it's everywhere. Actually, that you need to know, or otherwise you need to memorize. For a 95% confidence interval, it is always, especially when you use a Z value, it is always 1.96. How do I get 1.96? You go to the table, you leave the positive, you go to the negative side of the table, of the Z table, our normal table that we have been using all along, the cumulative standardized normal distribution. Inside the table, you look for 0.0250, and you go out and you go up, and you will see that it is 1.96. And that is your critical value. Like I said, you can just memorize this value. It will save you a whole lot of time, from confidence intervals to hypothesis testing. You just need to know, if I'm using Z, 95% confidence interval, the critical value is 1.96. Otherwise, have that table next to you. I will open the summary notes on Sunday so that then you can see what I'm talking about. And remember to have those summary notes printed or somewhere close by that you can always refer to when you are writing. It will help a lot. It will go a long way in helping you. Okay, so our critical value is 1.96. So let's find out all the other information given. The survey from 90 learners, N of 90. The average travel time is your mean, X bar, and our standard deviation is that. So we can just substitute 114 plus or minus 1.96, because our critical value, times our standard deviation of 72 divided by the square root of 90. Close bracket. And we can calculate. First, you start with the negative side first, and then you go to the positive side. Always remember that. So we go 114 minus 1.96 times 72 divided by the square root of 90. Out again, close bracket, equal. And the answer is 99. We need 2 decimal, 99.12. 99.12. And you go to the next question, which, oh, sorry, the plus sign. You use your arrow, your left arrow, go. Again and 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 again. And delete and a plus, or you can retype the whole thing again. There is no problem with that. And the answer is 128.88. 128.88. Which one is the correct answer? Which is option C. You see how easy it is. Okay, moving on. If there are no questions. A household survey based on a random sample of 50. So our sample size, which is N, 50 in a rural area, found the average household income to be 3,500, which is your mean, and the standard deviation of 1,000. Which standard deviation is this? Is this a sample or is that the population? And how do you determine that?
The statement.
Is this standard deviation the population standard deviation, or is the standard deviation the sample standard deviation? How do I know that?
It's a sample, is it?
It's from the sample, because the whole sentence was talking about the sample, and nowhere even they did mention something about the population. So they say with the household survey based on a sample of 50 in a small area found that the average household income is this with the standard deviation of this. Therefore, it means this is S, and therefore your population standard deviation is unknown. And when it is unknown, then automatically, you know, the formula will be T alpha divided by 2 and the degrees of freedom, and S divided by the square root of M. Now, since we have determined that, and the question says construct a 99% confidence interval, the same thing. What is a 99? A 0, a 99 is the same as 1 minus alpha is equals to 0.99. Therefore, alpha is equals to 1 minus 0.99, which is 0.01. And alpha divided by 2 will be 0.0. Am I calculating right? Or is it 2 or 5? I think it's 5. I am 0.01 divided by 2 is 0.00. So if the answer looks like this, which is an expression, so what you do is plus 1 and say equal and divide by, and remember that you put there a 1 in front, so we can assume that 1 is equals to 0. So the answer is 0.005. 0.005. That is the answer. 0.005. So now we need to go and find the degrees of freedom, and our degrees of freedom, remember the degrees of freedom is n minus 1. Our n is 50 minus 1, therefore the degrees of freedom is 49. In order for us to find the critical value, or which is the t, alpha divided by 2 and the degrees of freedom, therefore we're looking for t of 0.005 and 49. So we go to the T table, which is called the critical values of T. And remember the following. On the critical values of T table, you're going to ignore the top probabilities that you see there, which are called cumulative. We're going to look at the upper tail area probabilities, which are the probabilities closer to the table. Degrees of freedom, which is our degrees of freedom, and our probabilities are on here. Remember, we're looking for 0.005. And our degrees of freedom, so it's the last column you can see there, because when I scroll up, it's gonna disappear. And we're looking for 49 and 0.005. And therefore, our critical value is 2.6800. Our critical value is 2,68. Did I write it right? Yes, I did. So let's substitute. We know that we have 3,500 plus or minus 2,6800 times our standard error, which is 1,000, divided by the square root of 50. And we do some calculation. 3,500 minus 2.6800, open bracket, fraction, 1,000, go down, square root of 50. Right again, and close bracket, and equal. The answer is 3120. 3,020.99, which is that answer. And we go to the positive side in case they made a mistake. Oh, there are two of them. And we go to the positive side, and it's 3,879.01, which the answer is C. Can you see that? And that is how you do confidence intervals. Any questions? You will have to go and practice and find more activities and do more and more and more. Because if you are lost at this point in time, then I feel so together. Then it means there is still a whole lot of work that you need to do. So therefore it means also, please sacrifice your time. Tell everyone, boyfriends, girlfriends, husband, child, children, mother, grandmother, everybody, tell them that you will see them after the 8th. Funerals, party, all that. You're going to have to sacrifice all of them if you don't want to do that again next year. Because you need to practice and practice and practice. Okay, so moving on to the next question. Consider a T distribution with 18 degrees of freedom. Which one of the following statement is incorrect? Now, it means we need to validate each and every statement because there is not much that they have given us. The only thing that they have given you is the degrees of freedom. And after that, they have given you the alpha value. All you need to do is go and confirm. Go and confirm that all these values are correct. That's all what they want. So the between is the positive and the negative. It is, if I had to draw a graph like this, in the middle it's 0. So what is the negative value, the side, and what is the positive value? Your T alpha over 2, or your T alpha over 2 on that side, right? That is what they are asking you there. Now, what you need to do is, because they're telling you already that this is the degrees of freedom, this is the T distribution. So we know already that T distribution, in order for us to find the value or the T value, we use T and the degrees of freedom, or you use T alpha divided by 2, and the degrees of freedom. And now, because the confusion about this question is that you will never know whether is this part of the hypothesis testing or is this part of the confidence interval testing that we were doing earlier. Because there is a difference. Hence, I wrote those two distribution there. If this is a hypothesis question type of, or hypothesis type of a question, the t-value associated with the lower tail, which means only one side of it, will be given by only t alpha, because we're looking at only one side of things. If we're looking for two sides, then we're going to do alpha divided by 2. Hence, I say the tricky part with this is to determine whether is this a confidence interval or is this a hypothesis. So we will apply both in order for us to find which one of these statements is incorrect. So let's assume that the first two, because they're only talking about lower tail, it means we're going to only use one side. And the lower tail, like I said, sorry, my bad, the lower tail and the upper tail is positive, the lower tail is negative. So let's go and find out. A 0,05 is it going to be with 18 degrees of freedom. So let's go to 18 degrees of freedom. So we're going to always stay on this 18. So this is the line that we're going to be on, because we have the degrees of freedom of 18. That's what we have here, 18. We're only going to check all these values, a 0,05, 0,025, a 98%. So 98% is alpha of 0,02. So we need to go find, because it says between, and alpha divided by 2 of that. So you will say 0.02 divided by 2, which is 0.01. And for 99, alpha of 0,01, which is alpha over 2 of 0,005. We did calculate it earlier. And for 80, alpha of 0,020, and therefore it will be alpha over 2 of 0.2 divided by 2 is 0.01. So we're going to use these values for each one of them. Right. Okay, so now let's start with the first one, which is 18 and 0,05. So let's go there. 18 and 0,05. The answer is 1,7341. 1,7341. And it should be, because it says it's in the lower tail, should be negative. So that is correct. Okay. And then the second one, it says we need to go find on the lower tail 0,025. So we go to 0,025, which is that value. And the answer is 2,1009. So you go there, 2,10. So that is incorrect, because it says it's positive and they said lower. So this is the lower tail, this is the upper tail, like we did with the confidence interval. Always remember that your lower tail critical value will have a negative, your upper tail will have a positive. So we already have our incorrect answer. So if we look at 98%, it will be 0,01. It says it's 2.552. So at 0,01, 0,01 is 2,552. There we go. That's correct. Positive and negative side, which is correct. And if you look at 99, which is 0,005, it says it's between 2.878. Let's go there. 0,0075, which is 2.878, which is correct. Positive and negative side. And the last one, at 80%, we use 0,1, and it says it's between 1,330 negative and positive. 1,330, and which is the second one, 1,330. As you can see, that's how you will validate each statement to get the correct answer, by just using your probability value and calculating the between. The two statements, the first two and this three, the only catchy thing is that on the first one, they gave you the alpha value. On this one, they gave you a 95% confidence interval, and they told you that it is between. Hence, we used the alpha divided by 2, not on the second one, because it's just one tail, which we just use T alpha. So you just need to pay attention to that. And also, because we use the degrees of freedom, because they gave us the degrees of freedom. If they would have given us n, we would use the degrees of freedom as n minus 1. But they already gave us that degrees of freedom. So we didn't have to calculate the degrees of freedom. We just use it. Okay. We have 20 minutes left. We are on question 6. Let's continue. A simple random sample of 37 from a normal population results in a sample mean of 200 and a standard deviation of 50. What is this standard deviation? They already told you there. Some questions are easy because the information is given right in the beginning. Some questions you need to think outside of the box, or you need to think about the question. And sample size, that's our n. The normal population sample mean, which is your x bar, your sample standard deviation, which is your S, and at a 90% confidence interval. How it means, because we are given the sample standard deviation, we're going to use the T distribution, alpha divided by 2, and the degrees of freedom. So our alpha over 2 and the degrees of freedom is T of 90% is 1 minus alpha of 0,90, which means alpha is of 0,10. So that will be 0,10 divided by 2, and the degrees of freedom will be 37 minus 1, and you will have T of this 0.1 divided by 2 is 0,05, 0,05 and 36. You need to go to the T table. So let's go to the T table and look for 0,05 and 36. Remove all this ink. 0,05 and 36. So you just need to scroll. So because I'm gonna lose that, need to always remember which column is that. And we're looking for 36. And your critical value is 1,6883. 1,6883. 1,6883 times your standard deviation, 50 divided by the square root of 37. plus or minus your mean is 200. Do the calculation. Oh, I've been talking long.
One is 6.12.
186.12.
6.12.
12. Okay, let me double check that because I don't have comma 12. Maybe is it comma 12 and a bigger number? Because I only have 13 there. But it's fine. Let's see. 200 minus 1, comma 6.883 and bracket action 50. And I will also check with the table because sometimes the table they use is different to the tables we have. Is 1.22. So let's use only 3 decimals and see. Just want to check. Then when I use 2 decimals, okay. 2 decimals. Doesn't change anything. Okay, so we can also find the upper tail, which will be plus, and that will be option D. 2 and 3. 8, you see. They rounded off on the lower limit, but they didn't round off on the upper limit. Okay. So the answer is option D. Easy, né?
Can I ask you something?
Mm-hmm.
On this on the one that why did you put the 3 after the 1.83, 1.6883?
Because it's
Because when I check here, it's on the table T. It's only 1.688.
on the table that you are using. You are using
Yes.
three decimal table.
Yeah, it's only 3 decimal table.
Which table? Like where do you get that?
In table 40 distributions.
It's the table in our textbooks.
Yes.
Is it in the textbook?
Yes.
Textbook, yes.
Okay, so what I'm using and what we shared with you, these are the tables that are given in during the exam when people were writing exams
Okay.
physically, as well as I think in the previous years in tutorial letter 101 they would also include the tables that students can use.
Oh, okay.
And I will advise that you get hold of, but you can still use your tables. There is nothing wrong because These tables are 4 decimals. Your textbook tables are only 2 decimals. The other challenge is sometimes some of the tables are missing from your textbook. I don't know which ones, but if you have all the tables from your textbook, then you can use your textbook. Okay. Most of the schools reported the decline in the number of absences following the Education Transport Learner or Department Learner Transport Program and the school nutrition. In a sample of 90 schools from Sekhukhune District, 72 schools reported the decline in the number of learners absent. Construct a 95% confidence interval for the population proportion. And since we're going to use the population proportion, it's P plus or minus the point estimate plus or minus the critical value of alpha over 2 times the standard error, which is P 1 minus P divided by N. So in the sample, that's your N. The number of school, that's your X. A confidence interval, since we're doing a Z, alpha is 0.05. Therefore, your alpha over 2 critical value will be 1.96. And that is something that I always say. Remember this, especially for the Z. Those critical values are easy to remember and easy to memorize. Okay, so we are not given P. So we can calculate P. P is X over N. Our X is 72. Our N is 90. What is the answer? What is P, the sample proportion?
Zero point 8.
0.8. Then we just substitute 0.8 plus or minus 1.96 times the square root of 0.8 times 1 minus 0.8 divided by N, close bracket. Are we winning?
0.717.
0.717. So let's work it out. 0.8 minus 1.96. 1.96 open bracket fraction square root fraction 0.8 times 1 minus 0.8 close bracket, go down 90 out and out again and close bracket and equal. On the negative side, we have 0.72 or 717, which is that. And we can check the second one if it's the same. Delete plus equal 0.883. And the answer is option C. Easy, right? Easy, 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 easy. You just need to know how to use your calculator, how to find the critical value, and how to do the right calculations. Moving on to the, I don't want to start hypothesis testing. We'll start it on Sunday. Let me just check something. How many weeks we left with before you go, right? On Sunday, which will be the 29th, we will be able to do the last bit of it's just that this study unit takes long to explain and calculate. They are not as straightforward. So on Sunday, we will finish off with hypothesis testing, but it does not stop you from going and learning more about the hypothesis testing. All the recordings are there, your notes are there, go and practice, and you also have the same notes. Go see if you are able to answer the question on your own, and if not, then we will explain it further on Sunday, and then we'll look at assignment 5, which was based on study unit 11, 10 and 11, which is chi-squared and regression. And then we are done. That should be Sunday and a little bit of Monday, the 30th. Right. Then we have Sunday, the 5th, and hence I'm saying then we don't have a lot of time because we have Sunday and Monday to do the past exam paper, which is very important in preparing you. So let's make sure that on Sunday we do as much, even if it means us taking a little bit more time to complete the assignment, because I want to leave more time for the past exam papers so that then you can get more opportunity to go through some of these questions before you go write the exam. We don't have a lot of time left. We only have 2 weeks or 1 week and less, which is next week only, probably. We only have next week. But that does not stop you from revising on your own, going through the past exam papers yourself, asking questions if you don't understand on the WhatsApp groups, so that then we can help you. Okay, so and that concludes today's session. I will see you on Sunday when we finish off and look at hypothesis testing. There are only about 5 questions, and then we will be done. Okay, so remember with all this, they are already on, they are on the website, all the summary notes, or the revision notes, which are all the assignment questions. And there are also answers. So some of them you should be able to check if you are getting them right. Don't go through the ABCs and Ds and compare the answers, the options. What is the answer to question 9? It's option A. If you want assistance, you need to show how you're working out, because then we can show you how to work it. What are the things that you need to answer that question? Because only having options doesn't help you to know exactly when you get the same question with different numbers. How do you answer that question? Because then you don't know how to get to the answer. The only thing you know is the options. To answer question like this, the option is A. It doesn't help. Okay, so but the solutions are there, so you can go through them as well. Then I will see you on Sunday.
Okay, Lizzie.
Just are there any questions? If there are content related questions. If not, then I'm gonna stop the recording.